Welcome back. In this video we're going to go over the process needed to build a Ramsey AM transmitter kit from start to finish, including alignment. One of the reasons I chose to build this kit was because I needed some way to broadcast an AM signal to my several AM radios, because there isn't really much in my area in the way of AM broadcast. It's just a very weak area, and I'm also afraid that eventually AM will go away. And I just want to prepare myself for that, and I also like to be able to have guests over the house and play reasonably acceptable music through these vintage radios that I've collected. I chose the Ramsey kit because it was inexpensive and I wanted something relatively easy to build. I mean, I have a lot of experience soldering and actually building electronics, but I'm not an engineer, so I didn't want to have to kind of design anything, and I didn't want to, because I'm not qualified to do so, but I also didn't want to deal with, I kind of wanted the instructions to be forthright and easy to follow. Because the Ramsey kit was designed as a beginner's soldering project, I had my work cut out for me. So let's see how the actual finished product sounds. One of the previous videos I uploaded, I mentioned doing such a thing, and one of my viewers commented that the Ramsey kit doesn't sound very good. That doesn't seem to be the case. I'm actually getting a good, strong signal out of it, and it sounds amazing. I think it speaks for itself. And over here I've got a Zenith Royal 670. So as you can clearly hear, it sounds pretty damn clean. It's not a professional grade unit. It only broadcasts in AM mono, so, it's not perfect, but it does the job. Now let's take a look at the other end. For my signal input, I'm using this old all-in-one eMac as kind of a tuning device. I'm actually running iTunes using the Live 365 radio station Fusion 101. Which I can easily change at the click of a mouse button. But I prefer Fusion 101. It's one of my favorite stations of all time. And here's the unit itself. I have the tuning coil set to AM880, and it broadcasts a fairly weak signal. I actually tuned my car's radio to AM880, and I circled my building, and I was able to hear it probably within about 20 feet of the building. So, according to the FCC, I think that's within reason. Of course, when you build one of these kits, you have to follow and obey the FCC guidelines, otherwise you could be fined severely. But this is the unit itself. It's got a simple power switch. And that's that. As for inputs and outputs, we've got an antenna output, which I just have a single wire connected to the center pin. And we've got our audio level, which allows us to adjust the input audio so that it's not overdriven. And we've got our audio input, which is a monaural input. I do need to tie these together to create a like a 2-into-1 cable, because right now I'm only getting half the stereo signal rather than combined, so I've got to work on that. But anyway, that's pretty much all there is to it. And the next section of this video, we're going to go through the building process. It's a very long video, so have some popcorn and some whatever your favorite beverage is handy, and enjoy. So I went out and I bought one of these Ramsey AM transmitter kits. It was the right price, and hopefully it'll do what I want to do. Basically, I want to be able to broadcast music from one of my computers upstairs to the old antique AM radios I have in the house. So this is how it comes. Now, I've heard some pretty negative reviews, but I've also heard a lot of positive ones on this device. So I'm hoping that the positive reviews outweigh the negative, or aspects, I should say. The positive aspects outweigh the negative. So this is what the faceplate looks like. It just has a power switch in the front. And on the back you've got the audio level, audio input, antenna output, and a power supply input. It does not include a power supply input anywhere. I mean a power supply, so I have to come up with my own. Now I spent a couple of years building Anatech blue ESR meters and ring testers, so I know a few things about electronic assembly, I'd like to think. So let's take a look at what we have here. In this bag we've got our tuning coil, which is adjustable with this plastic prod. And here's our power switch. And this is, well, I don't know what that is. Let's look that up. Not sure what that is exactly. We've got our capacitors here. So let's first start by installing our capacitors. Okay, now the board is clearly silk screened to mark off what goes where, and we'll just start plopping components in. So the tuning coil goes in only one way, so we're going to just stick that in its spot. Once you insert the component, you want to bend the leads outward to keep it in place. This is the, you got two of these. This is RF out, and we have audio in. So the audio in and RF out both use this style RCA plug. Now getting these components installed is the easiest part. The other thing we need to do is take a look at our resistors and get them all identified, and then pop those in place. Okay, so this is a power switch designed to work in two different types of boards, which is why it has or two different types of installation scenarios, which is why it has lugs on both sides. But we just want to use these lower 6 legs, and that just pops in like that. Okay. Use a flat blade screwdriver to just kind of bend the legs out so that it doesn't come undone. This device is actually marketed as a fairly easy soldering project for young children. So, yeah, if I can't figure it out, I got a problem. But it all seems pretty simple, pretty straightforward. Pretty straightforward. Sometimes it's not even necessary to bend the legs, but I'm doing it just for fun. Okay, the capacitors are easy to put in because they are clearly marked for polarity. The long lead is your positive. Oh crap, the values aren't listed on here, so I've got to actually read the instructions. There we go. Should warm up my iron. This is gonna move pretty quickly. And in the instruction manual, what do we have here? Here's the capacitor guide. Okay. Tells you what they are. Okay. Here's the board diagram. See, the Anatech kits, the way we put those together was the board, I believe, actually had the values marked in a silk screen. So, 220 picofarad disc capacitor, marked 221 or 220. The disc capacitor is in here. Okay. C13, 14, those are all discs. Electrolytic. 310 microfarad electrolytics, C1, 2, and 4. And these are 220s, let's see. These are 10 microfarad. L3. What? Oh, C1, 2, and 4. Okay, so these go in C1, C2, and C4. And C1, C2, and C4. I should read the instructions just to make sure there's nothing I need to know. But I'm a man, damn it. I don't read no instructions. Alright. C2. Not sure if I'm showing up on the camera there. But anywho. Okay. So what are these? This is the 220 microfarad. There's one of those, and that goes on C15. You can clearly see that the spot for that capacitor is designed for a much larger one. It can handle two different size capacitors. I'm not sure why they chose the small one over the bigger one, but it could be a cost thing. And what was this? This could be the inductor. I gotta find out. I gotta identify that, actually. And oh yeah, here's our variable capacitor. No, variac. Or what the hell are they? What are these called? It'll tell me in a second. Tunable. Yeah, potentiometer. 1 5K PC mount potentiometer, marked 502. That's this one. And that goes where? CR12. And R12 is right here. This is our audio level adjust right here. So that's all pretty clean and fun. Now, I just got to figure out whether that's the variable inductor or the 48 microhenry, sorry, inductor. This tells you how it works. Identify Q6, a 2N3904 NPN transistor. No, that's not it. Switches in. We're gonna put this aside because I don't know what the hell it is. Yeah, I'll have to identify that in a minute. Okay, while it didn't include a resistor color chart, it did identify what the colors are supposed to be. So let's start with our resistors. There are 4 270 ohm resistors. That's red, violet, brown. That's not these. Looks like these. Red, violet, brown, and gold. There we go. And those go in our 6, 7, 9, and 11. So we're going to bend the leads like this, as close to the resistor as possible. Just like that. And we're going to pop them in place. R6 will be our first one. And that is right there. Resistors are not polarized. They just go either way. R7. R9 and 11. Pretty simple stuff. It's almost like Legos, but with soldering involved. So I just got to find R11. There it is. And just gently fold the leaves out like that. Eventually you're going to have a forest and we're going to have to trim that down. But let me finish building the rest of this. I'll do it on camera, why not? Maybe you'll find that entertaining somehow. Next batch of resistors are these. They are the brown, black, and red. No, that's brown, black, and orange. Brown, black, and red. There we go. These are our 1,000 ohm resistors, or 1K ohm. They go to R5 and R10. One thing I'm not really clear on is where the antenna goes on this. I thought this would have had a lug on the back for a wire antenna. But I may actually have to modify it a little bit. We'll see. R10. R10, where are you, R10? I know where R2 is. Okay, there it is. R2D2. Alright. Pop that in. Spread them. Next batch we have, actually I got to find the 2.2 or 2200 ohm red, which is R1. That'd be this one here. And that belongs in R1. Alright. Oh shit. Got that all wonky. Dagnabbit. Yeah, this is a pretty easy little project. I mean, anyone can do this. You and me. Alright. Next batch, we got our 10,000 ohm resistors. That's brown, black, and orange. And they belong where? R2, 3, 4, and 8. So there's R2. These holes appear to be drilled a little further out than the others. Because I'm not going in as friendly. R2, R3. God, this brings me back to my time at Anatech. This is what I did. After work, I'd drive half an hour to the guy's house and fire up the old soldering iron. I'd build, usually probably do about 2 or 3 units a night. I only worked for about an hour because I just didn't have the time. Then I'd have to drive an hour home. It was a nightmare. But it was great because I got to meet John, and you know, he was definitely a person that you'd never forget. He was that cool of a guy. By that I mean John Bachman, the founder Oh, it's Anatech. Anatech is still in business. His widow sold the company to somebody in California. And you can still buy the same products that John sold. Not sure how the customer service compares, but 2, 3, 4, and 8. Missing one? Yeah, 2, 3, 4, and 8. Where is, I see C8. Where's R8? That's R4. Oh, did I already do R8? Must have. Must have already done R8. Okay. Now there's other. So that takes care of all of our resistors. Now we got to do our disc capacitors. And there should be one 220 picofarad, marked 221 or 220. This is 222. So the 222s there's 4 of these, and they go to C13, C14, C9, 10, and 16. C14. And these are not polarized either. And this is a 222, so 2, C13. C14 one of them? Yep. Put that in there because I already found it. Put that in. Spread them. That just prevents the parts from falling out when you're, once they're assembled. That's all that's for. Here's another 222. C13, C14. C9, 10, there's C10, there's C9. I want to do these in order so I don't mess myself up here. And this is another 222 that goes to C10. And we have to find C16. Should be another one here somewhere. This is, I think I'm missing one. I'm missing a 222. I have a 471. .470, that goes in C9, 10, and 16. What? Okay, I gotta... Oh, I see. I gotta read the manual. Hold on. Okay, I had to remove C9, 10, and 16 because they're part of the final alignment procedure, I guess. Anyway, so let's move forward. We've got this green thing marked 100. And this, by the way, is called the diddle stick. Now, I didn't make that up. That would be... No way, man. According to the manual, that's what it's called. Yeah. This is a 10 microhenry inductor marked 100. This goes in L3. So we got to find L3. There it is. Doesn't appear to be polarized, so we're going to just pop it in there. Okay, there's that. 48 microhenry inductor, maybe marked 470 RC. Oh, that's what that is. Ah, yes. Okay. That belongs on L1. That's one of our inductors. That goes right here. Yeah, I really botched that one, didn't I? Let's try that again. Now, what you could do, in a case like that where you have to stretch a component across two widely spaced holes, alright, you want the leads to be straight. And then what you want to do is get a pair of needle nose pliers. I usually keep right here. I usually use a pair of precision pliers just for this reason. But you want to mark off roughly where the holes are. And you want to make your bends right there. That way it looks cleaner. And I'm going to try to straighten this out just a little better because I don't really like it. I think it looks like crap. In my opinion, the way it looks on the inside reflects the workmanship of the assembler. So I try to make my stuff look as factory clean as possible. Point of pride for me, you know. So I'm going to bend one lead. Make sure the component is like roughly in the middle. So that's going to go like right about there. Then I'm going to take my other lead. Am I capturing this? Not very much, not very well. Okay. My other lead, I'm going to kind of put the plier head right where it should bend down, and I'm going to bend that one to match the other lead. So right about there. And that way it looks like it belongs there, you know what I'm saying? Still not sure about those 3 capacitors. I've got to read more. There you go. Cleanly installed core. And we're going to bend the leads out. Good. Starting to build up quite a bit of a forest here. We'll get to that. This is a 221 capacitor. Where does that go? 220 microfarad goes at C15. Okay, let's put that where it belongs, man. C15, C12, C5, where's 15? Huh, I don't see one. It's really not a densely populated board, so I'm a little shocked that I'm not seeing it here. C13, C14, C12, 11, 3. Did I put something else there that doesn't belong there? What the hell is that? Somebody's doing some work outside. I gotta figure out why. Did it really say C15? It does say C15. I don't see a C15. Let's take a look at the board layout. Maybe I'm missing something. Turns out I had that mixed up with another part, but actually I was correct originally. So that was a 220 picofarad, not microfarad. That goes in C9, 10, or 16. Oh, okay, so that goes with these. All right, I think we're getting somewhere. Okay, cool. Now this is a little tiny one. Let's see where that goes. The noise turned out to be the propane gas guy doing some work outside. Apparently there was a leak that I didn't know about. K1J is what it's marked as, and let's see. 0.01 microfarad. I think that would be this one. It's marked 102. 103 or 0.01. We might have substituted a, yeah, 0.001 or 1 or 2. This is a 0.001 microfarad, microfarad. And that goes on C9, 10, or 16. Okay, so that goes in that pile. Jesus. Alright, okay, let's get these done here. These are our transistors, and these belong Q1, 2, 3, 4, 5, and 6. Now these, mounting these, you gotta kind of get the legs separated a little bit. You want to take the center leg and kind of push it out towards the rounded body. That's how I usually do them. And Q1, I gotta find Q1. It goes right there. Actually, I had that backwards. It goes the other direction. It goes towards the flat side. You'll notice that they're polarized, so the flat side goes towards the flat side of the silk screening, and then you just press them in like that. Pretty easy. And fold the legs out. If it's easier for you, you can always stop at any time and start soldering components down. Oops, bent it too far. Because working around all that forest is sometimes difficult. Q2. Sometimes what I would do is I would do all of my resistors first. Then I'd mow down the field. Then I'd do my capacitors. Then I'd mow it down. Then I'd do my all of my switches and LEDs and cut it down. Of course, we were working on boards that were much more complicated than this one. A lot more parts. A lot of resistors. Alright, Q4. Q6. Q7. Q5. Yeah, I missed Q5. And oh, so there is no 7, it just goes up to 6, so I just missed 5. Alright, good. And next order of business, we've got these green 103s. And they go to C3, 5, 6, 7, 8, 10, 11, 13 million. So C3, we got to find C3. Right there. C4. No, C5, sorry, C5. That's how mistakes happen. There we go. It's important, by the way, to get these components as close to the board as humanly possible. And that helps reduce the risk of leakage, electrical leakage. C6. Yeah. Okay. 7 and 8. Sorry if I have the camera angled away from me. I don't mean to do that. C8, C11, and 12. There's C12. I gotta find C11. Oh, C8. There's C8. I missed that one. And I already got C11. That's everything. Except for those final couple of capacitors. That's everything. Okay. Okay. Capacitors. So I gotta figure out what the deal is with those 9, 10, and 16. See, 9, 10, and 16. What is with 9, 10, and 16? So it says refer to the following chart for the values of C, 9, 10, and 16. What chart is that? I don't see a chart for that. Is this it? Yeah, this must be it. Excuse me. Alright, let me read the manual a little more thoroughly and figure that. Okay, so here's how this all works. So C9, 10, and 16 have to be adjusted based on the frequency you choose to broadcast at. What I'm going to do is use an AM radio to determine my broadcasting range. I need to find some dead space on the dial in my area. So I've got this Zenith Transistor radio, which is a reliable little piece of equipment, and we're going to just find some dead space in the dial. Between 8 and 10,000 kilohertz. So I'm going to choose that range right there. So between 8 and 10,000 kilohertz, we should have a 470 in C9. There we go. So I'm going to put a 470 in C9. Have a 470. Ah, there it is. 471. So that's going to go there. Okay. 2000 or I'm going to need a 222 in C10. And a C16 is not used. I also need to make sure that C4 is empty as well, because this is not being used with a microphone. The C4 capacitor is used only if you have a microphone that requires some signal boost, and we do not have that. So I got to find C4 and pull it. Where is that? Look at my board layout. Some of those silk screenings are kind of impossible to see. C4 is right over here. C3, that's it right there, C4. So we got to pull C4 out because we don't have a microphone. Our next step is the step you've all been waiting for. I'm going to put these resistors and, unused capacitors in a bag before I lose them, in case I decide to change the values later on. There we go. In case I move somewhere and I can't broadcast on that frequency. So, Fortunately, where I live, there isn't really much in the way of AM broadcast. We don't really get a whole lot, which is one of the reasons I'm building this to begin with, because I can't listen to anything if I can't get anything, right? Right. So, now we got to start soldering everything together. This is, got my hot iron ready, I got my solder ready. Let's go to town. Try to zoom in for you. Show you my method. It's worked for me. Maybe it'll work for you. Let's get my camera positioned. Okay, so there we go. Zoom in a little further. There we go. Freaking mount sucks, man, I tell you. Focus, you piece of shit. There it goes. Alright. Here we go. Now this one is not really solder masked, so the solder is going to kind of go everywhere. A good proper board would be masked so that only the areas that need solder will be visible. If you want to see what I mean, grab any random board from your collection, and you're going to see what I'm talking about. You'll see that only the areas where the solder pads are actually visible. Oh, that's a messy job right there. See that? Here's what I don't like about these. The solder tends to spread out larger than it needs to be on these types of boards, and they don't. Tracers heat up too quickly, and the heat dissipates too quickly. So there we go. Alright. I want to get all my structural connectors. And this is also not a very hot iron. I think this is only a 20 watt. So. One of my detail irons. Yeah, these boards are kind of a pain in the ass to solder onto. Well, not really. They're not that bad. They're just they don't solder as cleanly as some of the better quality solder masked boards. But those boards cost more to produce, and these guys aren't looking to. They're not really building scientific equipment here. They're just building, you know, easy to build kits. So, yeah, I'm losing my heat too quickly on this board. All right. Maybe I'll let it heat up a little longer before I start melting. Messy job. I should grab my hot iron. I have a better. What is this thing? It's a 15 watt. Yeah, I'm gonna get a hotter iron. This is not hot enough. This is an iron that I bought during Radio Shack's. We're not really going out of business, but we're kind of going out of business sale. Steady your hand. So here's an iron that I bought from Radio Shack's. We're going out of business, just kidding sale. It's a good little iron, 25 watt. Exactly what we need for this project. Hot enough yet? Yep. Okay, here we go. Oh yes, that's 100 times better right there. Nice, smooth solder joints. That's what you want. None of this blocky Flintstone shit. I love breaking in new soldering irons. All my good stuff is at work, and I'm on vacation, so I could go to work and do this, but I don't want to get hounded to do things that I don't want to do right now. When soldering posts or leads, always move the iron up to finish the joint. Go up the lead. There you go. There you go, just like that. You want it to finish off at a nice point. You can't really see that, can you? What do you want for free? Alright. If you're doing a lot of this stuff, you want to use a fume extractor. I don't have one in my house. I don't really do a lot of the stuff here, so there we go. It also helps if you have a board holder. When I was working for John over at Anatech, he had a nice little board holder. I should have grabbed that when they were selling off all of his equipment, but I didn't even think of it. I'm using leaded solder. It's a personal preference. Leaded solder just flows better at lower temperatures. It's also proven to work. And let's face it, I'm 31 years old. If I haven't had lead poisoning yet, then I've done something right. I've been doing this all my life, so I've had enough exposure to lead to last a lifetime. But yes, I understand that lead, like most heavy metal toxicities, accumulates in the body rather than not. And God, I wish I had my tip cleaner here. It's at work too. I should have bought 2 of them when they were on sale. You want to always drag the tip up the lead to finish the joint. Keeps it clean, keeps it honest. Am I still in frame? Yes. I'm going to work my way in. I'm going to do some forest cutting to make this a little easier as I get inboard. Yeah, nothing's worse than a cold solder joint or a solder joint where there's just not enough solder, and eventually it just causes all kinds of problems. It's no fun. Okay. Working our way like this. Around a clock like this, you know. Tick, tick, tock. We'll get the switch. These fumes do not make you high, so don't think about getting into this hobby to get high, because you won't. Although they can give you really cool cancers. Burning rosin is not really good for you. I really wish I had a board holder. Got one at work. I almost brought this to work to do it because that's where I have all my stuff. All my good stuff. My good tools. And yeah, it just didn't happen, so. I could go in there, but I'm like, yeah. I'm going to add some more solder here to stiffen up these joints a little bit. necessary, but yeah, that just made a mess right there, so I shouldn't have done that. We may have to change out those C9, 10, and 16 capacitors as we start tuning this device. If I can't get it to tune in on those frequencies, then that's what I'm going to have to do. I got some ash in the solder now. I got to clean this tip. I have a tip cleaner, but it's not. Actually, you know what I could use is steel wool, which I have plenty of. Let's take the tip into a pad of steel wool and go like this. There you go. That's one. Ow, that's hot. Ooh. Just use the steel wool to clean it off, just like that. That worked great. Actually worked marvelously. Okay, good. There we go. Where was I? Yeah, sometimes the rosin starts to burn on the tip of the iron, and you got to clean it off because it can contaminate your solder joints, and it just doesn't look good. Doesn't look good in your resume. Come on, baby. There we go. If you accidentally bridge two nearby tracers, it's not the end of the world. Just take some soldering braid and clean it off. I've done it more than my share of times. But you can see on this type of board, the solder just sort of spreads out. Normally it doesn't do that. On a solder mask board, that does not happen. So. Look at all this ash. It looks like shit. Oh man. Yeah. Well, the benefit of having solder with rosin core is it's basically a built-in flux. And the flux is necessary because it actually helps to clean the metal. It's like an acid that helps clean the metal first. And whoa, shit. Okay, we just set fire to some steel wool. Put this down. Don't want to cause another fire. Just let it smolder in the sink for a little bit. Shit. That's why you don't use steel wool to clean a soldering iron tip, folks. Oh man, did you see that? Steel wool is flammable because it has oils in it. And I didn't realize this was hot enough to set fire to it. Oops. Okay. Thank God I'm doing this in my kitchen and not upstairs. I would have a real problem on my hands. So don't use steel wool. If you do, get it wet first so it doesn't ignite. I forgot steel wool was flammable. I've actually set it on fire before using electricity on purpose. No, actually it wasn't. What was I doing? It was a long time ago. I was I forget what I was doing, and I somehow managed to pass current through it and shorted it out, and it caught fire. And it will smolder. It'll actually smolder, and it will burn the steel. Melt it away. It was lots of fun. There we go. Did I miss anything? Of course I did. Of course I did. Yep, there's one. There's like the rosin is just burning on the tip of my iron. I could use a regular old solder, and that wouldn't really solve anything. All right, got one there. Hey. That's an ugly one right there. I want to add to that. Look at all that ash everywhere. It's like Pompeii. Alright. I think we got them all. We'll find out once we start cleaning it up. Now I still have to clean the tip of the iron, so I'm going to use this sopping wet steel wool mesh. Just clean the tip very lightly, gently. Alright. Let our iron cool. If I need to plug it back in again, I will. Now we take our clippers, side cutters, dikes, whatever you want to call them. Let me zoom out. Ow! Let me zoom out. There's a cabinet right behind my camera here. I'm going to start trimming these off. I'm going to get a bowl. Follow the bowl. Okay. Oh, I missed one. Plug the iron back in. Yeah, I should just leave it plugged in just in case I find more of them. Got another one. Got another one. Okay, let's get these straightened out. Get those soldered up. Okay. Okay, I'm going to trim off the rest of them. We're going to take this toothbrush, just kind of clean up all the ash and slag from the soldering process. Clean it off there, and there we go. A little ball of solder here that doesn't need to be there. There we go. And voila, we're done. Completed board. Look at that. Now I just got to find a power supply that will run this, which I should have, and we'll be in business. I got the cabinet partially assembled. We need to get ready to get the tuning coil adjusted. I found a power supply that looks like it'll fit. 12 volt center positive. But I got to verify that with a multimeter first. Sometimes they'll throw you a curveball and they'll send you a power supply that you find in your parts bin can be reverse polarity and you won't even know it. Doesn't really say it either. On this one, it looks like center is positive, 12 volt. Good. Good, 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 good. I have had them reversed before. Scary times. Plug this in. There is no power indicator on this unit, so we're just going to have to assume it works. As for a video or an audio signal, I'm going to use my iPhone. I'm going to play some music through it, and we'll take a iTunes. Now I've got this audio cable. I have to get a different one, which is 2 into 1, so that I don't wind up with you know, obviously I'm broadcasting a stereo signal, condensing it down into mono, which you can't really do without a 2 into 1 adapter. So I'm going to be playing some Frank Zappa, it looks like. Okay, we're going to plug that into our audio in. We're going to be getting the left channel only. Power it on. Do a smoke test. No smoke. Okay. Now I've got to tune this coil. I know this is is going to work. You could also have the level turned way down, so I'm going to use the other tip of this to crank it up. Not a lot of electrical hum. Appears to be it. You can hear the iPhone making noise. I'm going to go kind of midway through the Oh, I don't have an antenna hooked up either. That doesn't help. I'll find something that I can connect to that. If at first you do not succeed, always check your work. And I point this out because even I make mistakes. Oh my God. Pity the thought, right? No, I screwed up. I don't know what I was thinking, but I put a... Now, hopefully I can recover from this, but... Because this is a serious problem. Can you see what I did wrong? I'll point it out to you. This transistor is in backwards. Idiot. So I have to desolder that transistor and put it back in the correct way. That's why this unit doesn't work. Now, hopefully there's no damage done to the transistor or any other passive components linked to it as a result of my mistake. These things happen. So that's just very real, you know. It happens. And... you know, when you're trying to rush something and you're not thinking, you know, that's what happens. All right, take two. So we're going to turn the radio on. We've got a power plugged in. Audio signal. Power's on. We have contact. Let's try different frequencies. Yeah, probably not a good spot of the dial. Well, I was warned these do sound pretty bad, but... Alright. That's not too bad. See how this one picks it up. I'll try to find something that isn't necessarily copyrighted. Let's see. Steely Dan, Donald Fagen. There we go. There's some music that was never released officially, so we're going to play some of that. There we go. There we go. Now this sounds bad anyway because it wasn't properly released. It's not picking up at all. It's between the 8,000 and 1,000 kilohertz mark. Nothing. Let's try Grandpa. Oh, that was on. Okay. Not picking it up either. No, not even. Nothing. Interesting. I wonder how far we can go away with it. Let's try a different track too. Ah, that explains it.